all possible outcomes in an experiment. This activity focuses on various ways to determine the sample space. So example 1, what are the total outcome of tossing 2 coins? Solution, each coin has 2 outcomes, heads or tails. So we are going to make an organized list. So we could have a heads on the first coin and a heads on the second coin. We could have a heads on one coin, a tails on one coin, a tails and a heads, or a tails and tails. So here are 4 total outcomes. So this list shows first coin heads, second coin heads. So that's heads, heads. Next one, first coin heads, second coin, well, since that's a T, that would mean tails. The next one says TH, so first coin is tails. Second coin is heads. Then the last one is TET, so that means first coin is tails. Second coin is tails. So this is the list. Okay, so this is the list way. This is the table. We could do, see how this is heads and heads, which make heads, heads. Tails and heads, head, tails. So this represents your first coin, these, first coin. And then these represent second coin. So one of the options is heads, heads, then heads, tails, tails, heads, and tails, tails, TT. So this is a table, a way to make a table. Then we have a tree diagram. So the first coin, so this first level is the first coin. So the options for the first coin is heads and tails. The options for the second coin could be heads and tails. So whenever you go heads, then heads, so that's HH. You can go heads, then tails, HT. Start off with tails, then heads, tails, heads, or tails and tails, TT. So these are called the outcomes. Or, how it says up here, sample space. Okay? Counting principle. Each coin has 2 outcomes. Multiply the number of each of the outcomes to get the total number of outcomes. So 2 is your first coin. And then you also have 2 options for this second coin. So that means that it'll be 4 total outcomes, and we already found those outcomes. Okay, so our sample space equals 4. There are a total of 4 possible outcomes whenever you throw 2 coins, of tossing 2 coins. Okay, so let's go to the next page. We're going to look at rolling number cubes. So that's also a fancy word for a dice. List all the outcomes possible when rolling 2 number cubes. Solution, make a table, fill in missing parts. So, see how it says row heading represents number rolled on second number cube. Column heading represents number rolled on first cube. So this is the columns. Here are your rows. So a 1 and a 1. You get 1, 1. A 2, 1. Okay, so first number cube, what if we roll a 3? And then a 1. Then a 4, 1. And a 5, 1. 6, 1. So then how can we fill out the rest of this? Well, the same way. We look at our column and then our row. So 1, 2. The next one would be 2, 2. Next one would be 3, 2. 4, 2, 5, 2, 6, 2. So these are whenever you're rolling the number cube. Okay, the next one, if we roll a 1, 3, then we have 2, 3, 3, 3, 4, 3, 5, 3, 6, 3. Hope you're getting the hang of it. So if we roll a 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 4, 5 on the second number cube, so this is a 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6, 5. The next one we have a 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, and 6, 6. So what we're doing is we're listing out the possible ways. If you're tossing a number cube, what are the total outcomes? So a 6, 2 in the table, so let's see, 6, 2 right here in the table means that the first number cube showed, well, it tells us the column heading represents on the first number cube. So the first number cube showed a 6, and the second number cube showed a 2. How many outcomes are in the table? Well, we could count them all, or you can see that this is 6. This is 6, so 6 times 6 is 36. See? What is the number of outcomes in the sample space of rolling 2 number cubes? Well, we just found them, 36. So this table shows all the total outcomes, or the sample space. Okay, the counting principle, though, it tells us that we can find outcomes for event 1 and multiply times outcomes of event 2. So how many outcomes are there in rolling 1 number cube? If you just have 1 number cube, your only options are 1, 2, 3, 4, 5, and 6. So we only have 6 if you roll 1 number cube. 6 outcomes. Give the number of outcomes in the sample space when rolling 2 number cubes. So if we have 2 number cubes, that is this table that we just got through doing. And we came up with 36. But using the counting principle, that says we could do outcomes for 1 cube. Well, that was 6. What about outcomes? We're rolling 2, so outcomes for the other one, the second cube, 1 cube. So this is the first cube, and this is the second cube. Well, it's also 6. So to find total outcomes, you could multiply those. 6 times 6, which equals 36. So that's a shortcut. So this showed you how to use a table and how to use the counting principle to find total outcomes. It's important to use the table so that you know how many or what the outcomes look like. But to get the total, you can just multiply the 6 by the 6. Okay, the next page. Practice. Make a list to represent sample spaces for events using list or tree diagrams. So remember what a list looks like. This is the list. This is the tree diagram. Okay, Claire is ordering a milkshake. She has a choice of small, medium, or large, and vanilla or chocolate. Make a tree diagram to determine the number of choices. So this is tree diagram. So let S represent small, M medium, L large, V for vanilla, C for chocolate. Okay, so my first choice is my size. I can decide what size I want. So I'm going to do size. So my options are small, medium, or large. So it's kind of separated out. My next option is the vanilla or chocolate, so the flavor. Well, if I pick a small, then I still have options. I have a vanilla or chocolate option. If I pick a medium, I still have the same options, vanilla and chocolate. If I pick a large, I still have two options, vanilla and chocolate. So my list, so that's a tree diagram. Now my list is going to tell me how many options there are. Well, I could do a small vanilla, so SV. I could do a small chocolate. I can do a medium vanilla. I can do a medium chocolate, large vanilla, or large chocolate. So this is my list. That's my tree diagram to get to that list. So now I list out how many. So 1, 2, 3, 4, 5. So 6 choices. 6 outcomes. Slash choices. So my sample space is 6. And I could have done the counting principle to know how many. So there are 3 options for small, medium, large, 2 options for vanilla or chocolate. 3 times 2 is the 6. But here I have the list. Okay, last example. The flyer shows a choice for a scooter. How many different scooters are available when choosing one color, one power source, and one style? Okay, so we'll start out with colors. Okay, so we're going to list it the same way. So color. So my colors choices are red, green, and blue. So R for red, green, G, B for blue. Then my next choice is gas or electric. So I still have a gas and electric choice for red. Same thing for green, gas or electric. And for blue, I also have gas and electric choice. Then my last choice is traditional or sporty. So here, if I go red, gas, then I still have traditional or sporty. If I go red, electric, traditional, sporty. Green, gas, traditional, sporty. Green, electric, traditional, sporty. Blue, gas, traditional, sporty. Blue, electric, traditional, sporty. So that means I can list out all my options. It could be a red, gas, traditional. It can be a red, gas, sporty. It could be a red, electric, traditional. Red, electric, sporty. So I did that whole tree right there. Then I could do green, gas, traditional. Green, gas, sporty. Green, electric, traditional. Green, electric, sporty. Blue, gas, traditional. Blue, gas, sporty. Blue, electric, traditional. Blue, electric, sporty. Okay, so we have all of our choices listed. So all we did was go down the line. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 choices. because that's what